Welcome to another very exciting episode of TeqTalk, where we discuss data, AI, and innovation. On today's episode, I'm thrilled to have someone who is an expert in databases and has led complex AI-driven data solutions. Welcoming Dr. Gajanan C on the show. Thank you, Gajanan, so much for coming to the show.
Oh, thank you for inviting me here. A nice place.
Absolutely. Thanks. To start with, would you like to talk about your career?
Yeah, I have a long career now. It will take a long time to talk about it. I'll try to summarize briefly. So, for a long time, I have been working in real algorithms and graph kind of problems from almost 1990. And then I entered into databases, finished PhD related to databases, where also again I used some graph theoretic techniques. And eventually I worked on a variety of databases. One interesting thing I always feel lucky about is that I got opportunity to work on object-oriented databases, relational databases, XML databases, SQL XML combination, full text search, temporal, graph, and vectors. So literally every kind of data structure, I have been able to work on closely in terms of implementations of query engines and indexing techniques.
Yeah, that is why I refer you as an expert.
I have been fortunate to get those opportunities.
Yeah, so I get you are at the right place where we can discuss about the evolution of database, right? So you have seen it firsthand that database has evolved from hierarchical to network to relational to NoSQL, graph, vector, and now to hybrid model. So what do you think are common factors which are leading organizations to move towards this multi-model or the hybrid format of database?
Okay, so this is an interesting question because, hierarchical and network databases existed even before my time.
Oh.
But then I started tracking from relational databases. So early relational databases were pretty useful because one of the ideas why relational model came into picture is that the application did not code how to extract the data. Application should only code what they need. What data I need, I should not have to say that how you find that data. And so that kind of shielding was achieved by relational model, and so as a result you can see its success. It's very significant abstraction,
right?
And it is whatever we say, whatever new models come, relational database is still going to be a dominant data model.
Yeah. And I think still like 60 to 70% of the organization are still heavy on relational
databases, and it will continue to remain that way. And in fact, usage even may increase. It's possible. So why this is so? Why this is happening that way? Because all online transaction processing applications, which are quite significant, they can be modeled very well in relational databases. Most of the databases are all ACID compliant. They have transactions, and so that was natural. But then there was a class of problems which was hard to model as relations. And that's where the ideas of object databases or object to relational mapping, that those came into picture. Because when you have complex relationship within the data and you have to traverse relationships, then if you try to achieve that using relational database, it is possible, but then you have to do lot of self joins or long joins. And that decreases performance. And typically, in an OLTP database, 4 or 5 the joins, beyond 4 or 5 joins, it is very hard for optimizers to do a good job, and also for the database to perform. Even if there is an optimum plan, still it will take long time for the query to execute. So for that kind of thing, so explicit storage of those relationships, that became an interesting part, and that's why object model came into picture. So actually in 1996, there was a very significant paper. I don't remember the title. in Sigmod, one of the top database conferences, which compared actually object model and object relational model. And it concluded that object relational model has won also. This is something vaguely I remember. This paper. This was a very significant paper. So what was the object relational model? Basically, storing objects in a relational database. So there are two ways of doing that, achieving that. Of course, you can really open up the entire object and store it just like a columnar database, but then it is a less effective way because you are shredding the object. Another way is that actually providing types in the columns, means in the language, query language, which can store objects. And that is one more approach. But then you might have seen a wave of OR tools also. There was almost a decade where people were using OR tools. Even today people use OR tools, because if you develop an application in Java, then you have to store the data in relational databases, then you really want that to be done automatically rather than doing it manually by the programmer. I have actually firsthand seen that, tried to implement it in an object-oriented database. It was very complex for people to code that. You really needed hardcore engineers to use the database. While the purpose of database is to make it easy for everyone to be able to use data. And so naturally, these are the reasons why object databases ultimately they didn't go anywhere. But then those people, when by the end of the last century, this W3C started this simplification of HTML and some new standards. So XML wave came. So many of the object database companies actually started supporting XML. They became XML, and some of them tried to become object companies also. And these are the days in which this even Neo4j started as a NeoDB. That period should have been like 2000 to 2006. If we look at the history today, it says that Neo4j started in 2006. But probably that was going as an internal project in some organizations even before that, for few years, 3-4 years before that, because I remember to have seen a paper from Neo4j which was in the early days, and its name was NeoDB. So
Right now, Neo4j is mostly into the
Graph databases. Yeah, so they tried to simplify this object representation. But then again, with XML databases, there were quite a few companies. Over the time, that also died. Two reasons, in my view. One reason is that the schema for XML schema standard, that became very, very complex. It was very hard for people to understand XML schema and to use it in day-to-day things. It is still in use. There are some applications where you definitely need that, and so it's in use. But it couldn't become as common as relational database schema kind of thing. Secondly, the query language. The XQuery it's very very complex as compared to SQL. Okay, so there was a time when thinkers in database world used to think that XQuery will take over SQL, but it was not possible basically. And so SQL Standards Committee in 2005-6 time frame, they actually integrated XML XQuery into SQL standards. So they did provide the interoperability between SQL and XQuery syntax level. For any large organization, if they want to change the technology, they will have to hire people with that kind of a skill, which those people are not available. That was another problem XQuery faced. So eventually, things. So graph databases, slowly they were moving. Neo4j was making slow progress until recently. I personally happen to work on a database engine which is a very powerful multimodal database, and it is MarkLogic.
Okay.
So MarkLogic had it started as a text search company, which evolved into XML XQuery kind of company. Then they also supported RDF, which became a graph, basically some sort of W3C standards, graph standard. Also supported JSON storage natively, JSON querying natively, temporal, bitemporal querying natively. So it becomes very rich multimodal data system. But the company grew, the company survived also. But again, the most of the people were familiar with relational technology, and they were happy with that. And for non-relational kind of things, even simpler simpler database like Mongo became more successful, because Mongo was relatively, it was easier to understand than the XQuery based programming of MarkLogic database. And then recently, all of a sudden in 22 or so, people, when this Gen AI became more popular, then people realized that, oh, we should be doing hallucination became a known problem, and then people wanted Retrieval Augmented Generation, RAG, and then they started using vector. So vector databases took off in the last 4 years only. Prior to that, some vector databases existed, and their goal was actually to provide similarity search. So search, that is another piece which is very closely related to databases, but it is different also from databases. Traditionally, databases are seen as exact search kind of systems. So if you run a select query,
It was not similar to
so if you run SQL query, you get exact results. But if you look at Google search, right from say like last 25 years, if you, or any engines which existed before Google, that like Alta Vista and Yahoo and all those, so they were giving you approximate results. So approximate query processing was one of the research areas in database systems also. But commercial databases never supported approximate query processing. They were doing exact query processing, and that was what most applications needed. So that's the whole story. But then now, if you look at search, actually, what is the origin of search? That is a whole field of research called information retrieval. So databases and information retrievals, which were really two independent fields evolving independently. Similarly, AI was evolving independently for last 40-50 years, or maybe 60 years actually. So at some point, but in around after 2000 or so, I have started seeing some researchers publishing papers, and the two areas were coming together: information retrieval and databases. And so companies were, anyways, relational databases were trying to provide simple text search, but they could never do it as well as the text search engines, but they did try. So, and B-tree indexing is very difficult on text search, and relational databases are mainly, they work on B-tree indexes basically. So but that text search was based on keywords, and maybe distances between the words, or maybe coexistence of two words, find out all the documents which coexist. So you give two words, for example, the room and browser. And if you say that, okay, find me all documents which are containing these two things, or these two within the distance of 5 words. So distance queries, coexistence queries, all that kind of thing was search basically. And it was approximate search, that is one part. But secondly, there was no way to express any semantics in it. So vectors, it is claimed that, and it is still believed that they capture semantics reasonably well. But there are also studies where people claim that if the text is very long, then vectors do not capture semantics very well.
Some limitations.
Very well. So also, people started then combining these vector techniques with search, and that's what started happening, say, after 2014-15 time frame. So very significant thing happened in 2024, that somebody from Microsoft Research, they just published a blog. So sometimes, how things catch up and how the fire catches up, it's very unpredictable. So Microsoft researchers published a blog saying that GraphRAG is better than vector RAG. And all of a sudden, everybody became interested in graph databases. And so now here we are today, where people are talking about graphs, vectors, and relational data is going to be there no matter what.
So one of the reasons which I have understood that organizations are moving towards multimodal or hybrid is because of the boom in AI, ML, and they need to have a quick extraction and similar extraction of data, right? So one of the reasons I have understood, and other one is like the speed, which matters a lot. So relational database, if it become like how you mentioned before, that if you have to query something which is having, for example, friends of friends of friends, if they have to find out something, right? So you have to put on a lot of joins, set joins, or multiple joins. In that way, the query becomes very slow to run and impact on the performance. So that could be one of the other reasons that organizations are thinking to move toward.
Why organizations have to move to other models other than relational databases?
Yeah.
So this is very interesting. You are seeing what is happening today.
Yeah.
This need existed always. That is because large amount of knowledge in an organization is stored in spreadsheets, Word documents, PDF documents, sometimes pictures, images. So that has been there. So there used to be in olden days, even before the age of web, internet, there were companies doing content management. And one such company I worked for was Documentum, which was number one content, supposed to be number one content management system. So this system would manage PDFs, Word documents, XML documents, images, all kinds of things. And interestingly, with the technology that was present or available in those days, I believe Documentum might have been started in 80s or at least early 90s. So they used relational databases to actually index this data.
Okay.
So whenever if they had to give a full text search query, internally this system would first split the query into a SQL query, generate a SQL query to go and get the metadata from relational database, and then run a full text search on those contents.
So even on unstructured data.
On an unstructured data. Of course, there were hardly any technologies available for querying images. Even today, there are really few and very small players in that space who can do image querying and all that. It will evolve now.
Yeah.
It is going to be important. But as such, if you see enterprise class products, there are hardly any. So Documentum kind of products were used in large organizations truly. So relational data and non-relational data, this problem always existed. People tried to find solutions for those problems, but now what is happening is that the amount of data that is generated is increasing. That is one part. And secondly, today because of this whole Gen AI thing or the progress in natural language processing, it is possible to consume that data. That was not possible to consume it so well in the olden days. Yeah.
So I think the volume of data also matters.
Volume of data has increased.
Yeah,
and
these organizations are slowly thinking of
getting, and and also there is commercial aspect to it also, because if people have beaten up on whatever is available in their databases and made maximum out of it, they'll always try to see, okay, other than this, that I have so much of other data.
Absolutely. I think that was very well said. And thank you so much for telling all the history of the evolution of databases. Very insightful. Let's talk a little bit about a vector database in detail, right? So we have seen a vector database being used mostly in the recommendations engines like Amazon and Netflix, where they recommend the best product, the best show. And also in some, if you take small e-commerce sites where they recommend the best products they have, and also for semantic searches, right? So let's go a little bit deep dive and understand that what is the mechanism behind indexing on a vector database? How does it work?
Okay, first thing, I will deviate from your question. So being a long-term database person, 30 years, I never believed in the idea of vector databases. Vector database is not a database. A vector database is basically people some people could raise money and they could call it a database, but really, what are the minimum necessary qualities of a database? Database should have a query language. Database should have some sort of consistency model. Database should have ability to update. All those kinds of things, and then enterprise features like security and all those things are different. Yeah, replication and all that is different problem. So vector is simply a type.
Yeah.
And it is a bulk type. So if you look at Oracle, early days of Oracle or early days of even IBM DB2 or Sybase or anything, we always had these large data types. Okay, so images, binary data types or text data types, which were bulk storage data types. Of course, depending on the technology and the era, they had limitations of sizes. But there were these types, and it was possible to create columns of those types.
Yeah.
So XML was also introduced the same way by the Standards Committee, SQL Standards Committee. XML was one type. XML is a type. JSON is a type. When you say create table and then you specify types, you can specify one XML type, one JSON type, whatever. Yeah. So that's the story. So vector is one such type. Okay. So and also in vectors, unlike XML and JSON, where it is possible to go inside those documents or those JSON objects and to query fields and subfields, which is not possible with vectors. Vectors is basically only similarity search. That this is the vector. You find out either cosine similarity or other L1, L2 norms and those kinds of things basically. So those kinds of similarity measures are available on vector databases, which is not a big deal. Means it's not really even a query language in that sense, a typed and schematized query language, anything. So I think vectors databases is a overhyped term, and it did prove. I mean, this did prove correct already, because every other database implemented, even Graph databases implemented vector support, isn't it? And so that is one part. Now vector indexing, most of the vector databases themselves, they are actually implementing HNSW index, which is a layered graph approach. And there are some variations. So the purpose of all these indexes is ultimately to reduce the search space. So what is the problem with vector search? The key problem is this. When you want to compute similar points or dissimilar points, whatever it is, you are in a space, vector space, which is say like 1500 dimensions, or 700 something 80 dimensions, whatever is this, depending on the embedding size, vector size. In that space, you have that many floating point numbers in your query vector, and then you have so many of those, millions of those vectors of that floating point size in your database. And now you want to do those computations. All of these need GPU.
So
and this
computation is pretty high,
very expensive. So the more clever you are in terms of eliminating the vectors which need not be compared, the better or more efficient, cost effective you are actually, and also performant. Performance is the thing we see, but in reality it boils down to the dollars cost you pay, isn't it? Yeah, performance, sometimes you may be able to, many use cases you may be able to say that, okay, if it takes 10 milliseconds more or 100 milliseconds more, I can still,
that's still okay.
But at the end of the month, if you are getting huge bills for GPU usage, that is significant. Yeah, it's a question of survival of a business.
So let's talk a little bit about the graph database, and we know that it works on edges and nodes, and so it seems to be powerful but tricky as well, right? When concurrency can be a real problem. So how does anyone, especially the organizations, be assured that whenever the data is heavy, the data is fluctuating heavily, but it is getting consistent?
That is the point. And honestly, that problem doesn't differ much from relational databases. the same techniques that were used for consistency maintenance or consistency models in relational databases is like optimistic concurrency control, pessimistic concurrency control, and then came this whole MVCC thing. Those things are needed. But let's actually look at the problem, peel the onion in slightly different way. So graph applications, where concurrency becomes a problem when somebody is updating the graph and somebody is reading simultaneously. If you look at modern Gen AI and RAG kind of applications, they are more read heavy. No, the updates are not happening. Those are not like OLTP as well as Gen AI RAG kind of databases. That is one thing. So that problem is less significant. But there is very interesting work which was done about 10-15 years back, I think, at CMU. I don't remember all the details, but Carlos Gerstein, he's a professor at Stanford now.
Okay.
He had a project named GraphLab. There, they have done some consistency studies related to machine learning on graphs. Because they were trying to parallelize graph operations to achieve higher performance. And in the parallelization process, if one CPU is updating a node and other CPUs simultaneously reading it, then what will happen in the model training? If you look at recent databases, graph databases like Amazon Neptune or even Neo4j, all of they are transactional ACID compliant databases. Yeah. So consistency problem is taken care of by these databases. But what remains to be seen is that these databases have Neptune. As far as I talk with many of my colleagues who worked on Neptune, it has been tested on some large graphs. I know that for complex queries, many of my colleagues who used some of these databases, they said that they do not perform well. But in terms of handling large amount of data, Neptune, for sure, people said that it has been able to ingest and it has been able to represent.
All right. Yeah, that's again very insightful. Thank you so much for sharing all those details. So moving on to another question. So combination of vector database and graph database, right, makes things very, very interesting. So do you have some real use cases of any organization or, in general use cases which are implementing both graph and vector and they're getting amazing output?
There are multiple things to be commented here.
Yeah.
First thing is that I don't know of many organizations which have RAG systems in production. Okay.
So still everybody is trying and pivoting and keeping the lower environment.
And for last at least 1.5 years, I have been asking this question to every user of Gen AI systems, that what do you have in production? Do you have RAG in production? So I don't get that answer. Most of them are in prototype stage. So that making a claim that this really gives, in this case it is giving this much benefits, is difficult for me personally because I have not seen it. Some database vendors have tried to publish articles, and you may find them just by googling that in this use case it is giving better performance, and they might have tested it with some of their specific customers on specific use cases. The one very interesting case experiment I have seen personally is that one of my colleagues was building a recommendation system.
Okay.
And for this recommendation system, he mapped all the available data as a graph, because it manages relationships very well.
Yeah.
But then from each graph node, he took some interesting properties, and on those he constructed a vector index, vectors, basically embedding. And then he connected that embedding with a link to the original graph node.
Okay.
Now what happens is that you have both graph and vectors together. And then he was able to search either way, either going from graph site performing a graph traversal and finding a node and seeing if it finding a vector and then finding it is it similar to the query being asked, or otherwise first hit the vector and then go back to the node and try to find out all the data, relevant data about that node. And it was a very powerful demo he had built. I have seen that. So which definitely it's a very convincing approach for recommendation system. But going further now, if you look at this kind of a system where you have graph nodes and with so many different types of relationships without the within the node. So for example, if it is a recommendation system, then there are products, there are categories, then within each orders, then manufacturers and all kinds of things, orders, and then you have these vectors. So now if you want to store both of those things, and similarity searches particularly need GPU, heavy GPU computations, while graph traversals need CPU computations. Okay, so achieving those two, I know that some people have thought of using vector databases and graph databases together, so that it becomes a two database system.
That is what hybrid, right? That is what multi-model databases is.
No, not really, because those are two separate databases. It's not. Multi-model means it will actually be able to do all that together, isn't it? So you will have same consistent query language, and you can run one query in which you can specify a predicate of similarity type, and you can also specify a predicate on graph path, or maybe on a property of a node or property of a link, all that.
So multi-model is still being talked about, or
multi-model, yeah, multi-modality is being talked more in terms of AI models, because when it says multi-modality, that means image, text, and video, audio, all kinds of data.
Right.
And if the models, one model can handle all these kinds of data, that would be a really golden solution for many organizations, and that's what is being worked. But multi-model databases, there are hardly any multi-model databases that exist. Relational databases were extended to do some specific things, but not really multimodality effective. Multimodality effective.
Yeah. So I think this is again a kind of a futuristic
thing. Yeah. For sure, AI will need more and more multi-model kind of storages. But we have to see. It is yet to be seen how this whole thing evolves.
Yeah. Right. So if any organization is thinking to, go ahead with the hybrid approach, which is still not existing, you said, right? Do you have something in mind, even if they want to go ahead and start with the hybrid database, that what are the recommendations or strategies you would suggest then?
I have suggested a couple of types of solutions to people who came to me ask with these questions. Definitely, you can try using Amazon Neptune.
Yeah.
If the cost and the performance is acceptable to you, then that is a way to go, because you will also get vector databases right there. But other solution is that I would suggest going with Postgres, basically.
Postgres.
Relational database and vector, it also you can achieve more or less similar things. You may not be as good as a graph database, but it is still better than the existing graph database products. Because in the existing graph database products, if they don't scale, then you may have to re-engineer the solution eventually. While Postgres, you at least don't have that kind of risk, because there are scalable Postgres implementations available. So you can go from a small on-premise Postgres database to a larger cloud ones, and at least scale.
Yeah.
So you can be little bit, you can shield yourself from reworking all things. But of course, I know that for sure graph database vendors are also trying aggressively, and if other graph database vendors like Neo4j or Dgraph
to embed the vectors,
they are also trying. So but the results are yet to be seen and proven.
Yeah, absolutely.
At least I don't have first-hand experience to say confidently anything.
I can completely rely on your talks and statements, because this is what your energy is going on, right? You are all into the databases and you know in and out what is coming in and what is the current trends and the future trends. So completely reliable information, I would say. And so tell me a little bit more about the future of this database. So how do you think, like, down 5 years down the line or 10 years down the line, what kind of capabilities a database would have and how easy it would be for the users to use it?
Oh, that, there are many things that are likely to happen. We can basically,
Just
it is
prediction.
like, yeah,
Might
prediction.
happen,
We
might
can
not
we can imagine relational databases for online transaction applications. They are not going to
not.
go anywhere,
Yeah.
isn't it? Similarly, analytical databases like Redshift and Snowflake are not going to go anywhere. That is going to increase. But the thing, what might happen is that the models will actually start working on large scale data very well. And so all these vendors will be able to work well with the models. And as a result, it might happen that the interfaces, the way we are using these databases today, that may change.
Yeah.
And we will see more of agentic. So if it comes to SQL database, yeah, you will have some natural language to SQL translations and agents talking with you. So maybe eventually you will have audio agents which will just get your command, translate it internally into SQL, get the answer, convert it into audio and give it to you in audio. Modes will change, but you will still probably be able to using these tools, the same databases, same kinds of tools underneath. The abstractions on top of those will increase.
Yeah, absolutely. That's again a very good point. Thank you so much.